Today I will show you how to create a 4-bar linkage mechanism using Solidworks. First, go ahead and create a new part. On the top plane, press right click and select sketch. Select the sketch and create a rectangle from origin. And I choose the width to be 1 inches, and here I call it width, and I choose the length is about 10 inches and call in the length of linkage. Now I'm gonna go ahead and extrude from the mid plane about 0.5 inch, and I'm gonna go ahead and select this face, right click and select sketch. I'm gonna press the Control key and the 8 key at the same time and make it a normal view. I'm going to draw the two circles of equal diameter. Hold the Control key, select this circle and this circle and make it equal. Now make the distance between two circles to be 8 inches, and this circle is 1 inches apart. Now I'm gonna select this and make it horizontal. I'm gonna select the center line, select the center of the circle and this line, and select this point and this line and make it the midpoint. And make the dimension for the circle is 0.5 inches. Now you can see my sketch here is predefined. Now I'm gonna do the screw cut and make it through all. Here's my linkage. Now what I'm gonna do is to create the equation. That is, if I first go ahead, right click on the annotation and press show future dimension. So if I change the distance between the two pins, the length of the linkage will change automatically. So first go ahead and enable the equation. If you don't have it, go to the tool option, or you can also go from here, select the feature manager and press show and press OK. Then you will see your equation bar right here. Now right click on it and select manage equation. In the equation block, select the length of the linkage and set it equal to the distance between the 2 points plus 2 inches. So if I make this one 10 inches, this will change the length of the linkage automatically to 12 inches. So I go ahead and press OK. For checking, just double click on this and press 10 inches, and I do the rebuild, and you can see it changed the length of the linkage automatically to 12 inches. Now I'm gonna, for the 4-bar linkage, I need 4 linkage. So instead of making 4 different parts, I'm just go ahead and create the configuration in the same part. So for this, I can either go ahead, right click and make and add configuration, or I can also go to the insert table and design table, select the auto create and press OK. I select all of them and make it large. Now for the 4 bar, I need the ground link, L0, the input, the cranker, and the output. I make the weight for all of them to be 1 inches, and for this one remains same. This one also choose to be the same. The diameter also choose the same. This one I make it this +2. So if I choose the distance between these 2 pins, for the L0, which is the largest link, so I choose to be the 40, and the L1 I choose to be the, which is the input, I choose 10 inches, and L2 the crank I choose to be 20, and the L3 the output I choose to be 20. And let's go ahead and change the L to the L3 to 30, the output, and I right click on the anywhere on the screen, and the Solidworks will automatically create the 4 new configuration for me. Go ahead and press the OK, and now I save the part. Link configuration. Now I'm gonna go and make the assembly from it. Select the link and press OK. I go back to the linkage configuration and select the annotation, unselect the store feature dimension. I go back to the assembly and make, this is supposed to be my L0, so I'm going to go ahead and change the configuration by right click on it and select the configuration component, press OK, and then make it L0, which is our ground link, and press OK. Now you can see the Solidworks automatically change the length. Now I need to add the input linkage, so right click on the linkage, press Ctrl and drag the new link, right click on it, configuration, and select L1, which is our input, press OK. Now I'm gonna go ahead and make it mate, so press S, mate, the cylindrical pin, and for the input and the ground link, make it constant, press OK, and select the input face and the linkage face and make it constant. Now you can see that the input can rotate about the ground link. Now select just right click on this link, control, and drag another part, and this is, and change the configuration of this to the L1, which is our L2, which is our the crank. Press OK and make this one, this cylinder, make it mate with our input. Make these two faces coincidence. Now for the output, I'm select this face, right click, select this face, control, and drag a new link. Right click on it, configuration, select OK, press L3 and OK. Now select this cylindrical face, select mate, select the ground link, make it coincident, press OK, select this cylindrical face and the crank pin and make it coincident, press OK. You can see now I'm gonna go ahead and make, select this face and this face coincident, this face, oops, cancel. Let's see what's okay. Here we go. Here is our 4-bar link mechanism. Now press Ctrl and 8 to see the normal view. Now for motion analysis, I go ahead and press the 2 add-in and select that Solidworks design motion. Press OK. I'm gonna go to the motion study one and add the motor on the input linkage so it can rotate about counterclockwise. So here, make sure you select the rotary motor, and you need to put the motor on here. So just select this. This direction shows you this. It's going to rotate this thing about counterclockwise. For study purpose, I'm just assuming 10 RPM just to showing you. Press OK and press Ctrl 8 and I go ahead and press the calculate. Oops. Oh, when I need to add the coincidence relation about this mechanism and this mechanism, press OK. I can see this mechanism can rotate. Now I'm gonna go ahead and I think I chose really slow RPM, so I'm gonna go ahead and make it 3 seconds. I'm gonna go ahead, right click on it, edit feature, gonna go ahead to about 50 rpm, press OK, and then recalculate. Go ahead, edit feature, go ahead and select this face, press OK. Now you can see how this make it 0.25. Now you can see the maximum transmission angle is when the input makes a 180-degree from the ground link, and the minimum transmission angle is when the input makes 0°. For example, just gonna go ahead, go to the model again, and as you see, the transmission angle is the angle between the output and the crank, and I can see my transmission angle is maximum at this point, and minimum is when the input linkage make 0° from the ground link. So this finished the tutorial of the 4-bar linkage mechanism.